Okay, so properties of expected value. So we'll say let x be a random variable. So if x is a random variable, then the expected value of a discrete, the expected value of a discrete probability is defined mathematically as so we are saying mathematically it's defined as expected of a discrete is equals to summation from the first to the nth xi times the probability of each corresponding hex. Then this is how we define the expected value. So this formula we should all know it. So if we are looking for the expected value, this is the formula mathematically. So mathematically we are saying it's x, which is a random variable, times its corresponding probability. Then when we sum up, this is the summation symbol. When we sum them up, then what we get is what we call the expected value. And the expected value is the mean. So the expected value is the mean of the distribution. Then whereas the variance, so now we are saying whereas the variance is variance of a random variable x is given by summation of x is squared times px minus summation of x px, then this entire thing is squared, which is just simply implying that the expected value of a random variable x is squared minus the expected value of x, then that expected value of x is squared. So this is the variance of a random variable. So this is the formula that is used for the variance of a random variable. Then we can look at some good properties. So we'll start with the properties of, so we'll look at the properties of expected value. So properties of expected value of a random variable. So we'll look at some few properties of random variable. So we are saying let A and B be arbitrary constants. So A and B are arbitrary constants. So these two are constants. That's what we are saying. These two are arbitrary constant. What it means is they can be any numbers that you can be given. Okay, so it can be any number that can be given. So those two are arbitrary constants, A and B. Then the first property is that if you have the expected value of a constant attached to the variable x, you can remove this constant outside and have the expected value of that. This is property number one. What this means, example is, if you have the expected value and then there is 2x, what it means is you can bring this 2 outside and have 2 times the expected value of that random variable. That is property number one. Any questions before I proceed to the next property? Okay, so the second property is...
I have a question.
Yes, what's the question?
What topic is this?
What topic is this? It's a discrete probability. Now we are looking at expected value and variance. So this is the part that was left in discrete probability, which I said we will do it the next time we are meeting, and we are meeting today. Are you people able to get me?
Yes, sir. We're able to get you.
Okay, so it means it's not my problem, those that are saying they can't get me. It means it's their gadget. Okay, so this is the first property of the expected value. Then the second property is, if you have the expected value of two random variables, x can have the constant a plus b also with a constant like that. The property states that you can split these two and have it written as a expected value of x plus b expected value of x, like that. So the first thing is, this is called the linear property. So this is the linear property. Similarly, for this one, you can even have a property which is, if you have ax plus b, like that, we know a and b are constants. Then what you can do is, if you have these two, so this is a linear property, we are saying this can be written as expected value of ax, like that, plus expected value of b, like that. Separate, you can have that written separately like that. So the main property that the other property, the third property that we'll look at is, so we are going to the third property, which is, if you have the expected value of a constant a, you've seen this a does not contain a variable x. The answer is just simply a. Example is expected value of a number, let's say 3. The answer is just simply 3. That's the meaning of that. Even if we had a similar case, like if you are asked to find the expected value of 2x plus 5, what that simply means is that you can split this using the linear property. It will turn out to be 2x, expected value of 2x, plus expected value of a constant. And then this will turn out to be the 2. You can bring it out. So you can have 2, then expected value of x, plus expected value of a constant, as long as that constant does not contain the variable, it's just the constant itself. So this is coming from the linear property, which is the second property. But our main concern is that the expected value of a constant will give you the constant itself. The expected value of a constant will give you the constant itself. We can now look at, I think, the other properties, if there are any that have been left out. We'll look at them when we do one or two examples. So then we'll look at the properties of variance. Properties of variance. So for the properties of the variance, we know A and B, we are saying they are constants. So if you have number one, the linear property for variance, if you have the variance of AX plus B, what this simply means is that you can have this split into two as the variance of AX plus the variance of B. But then the second property will tell you that if you have the variance of AX, remember for expectation, this constant A, we were just bringing it out. But for variance, when bringing it out, when it comes out of the variance, it comes out as a square. So it will be A to the power 2. So you square it. Then you can have the variance of X like that. Example on this one is, if you have the variance of, say, 3x, what this means is that this 3, when it's coming out of the variance, it will be squared. So it will turn out to be 3 squared, then variance of x, like that. Then this will turn out to be 3 squared, that will give you 9, then times variance of x, like that. So that's the third property. Then, or that's the second. Then the third one is on the variance of a constant. What does variance say about a constant? So if we look at A is just a constant without a variable. The variable is x. Now when we have variance of A, what that simply means is that variance of a constant is 0, regardless of the number. For example, variance of 2, or let's say 20. Variance of 20, as long as this number is a constant, the answer is just simply 0. So variance of a constant will give you 0. Any questions? Any questions? Oh, okay. So when people have no questions, it means that it's clear. There was a comment that said, I'm too fast. Am I fast?
Yes, sir, you're too fast.
Yes, I are too
Yes,
fast.
yes.
A bit faster.
When I become slow, you won't like me. Okay, so we are saying the variance, this is the variable, x is the variable, like that. Okay, let's have this information now mathematically as an example. I know my students very well. When we give an example, they will be happy as if they are not complaining that I'm fast. So let's have an example. So let's get one example so that we can be happy class. So example, okay, so example, the number of patients being discharged from the female ward the number of patients being discharged from the female ward with the corresponding probability with a corresponding probability of coming back for review is given in the table below. So for the students to take a screenshot or the notes before they say I'm very fast, you can take screenshot of the question before I draw the table, before I'm accused of being very fast. So just tell your friends who are joining to join also fast so that they don't distract me. They keep on joining, others leaving. I don't know where you're staying, if the network is terrible. It's just the gadgets that you are using. Okay, so away from the gadgets and these other scenes of the world. So avoid itel phones to have a stable network. I think iPhone is better for a network, but just the battery that is bad. The table is this: number of patients, okay? So we have the table. So number of patients, then we have
Sir.
probability of coming back for review. Coming for
Sir,
review. Yes, sir.
can I see the question one more time?
Sir, can I see the question one more time? One more time.
Okay, thank you.
All right, you're welcome, sir. So there we go. So we have that number of patients that are being discharged and their corresponding. So that's our table. So we have 1, 2, 3, 4, 5. 5 patients. Then if the corresponding probability of coming for review, we have 0.15, 0.2, 0.18, X, and 0.3, like that. Questions. Number 1, find the value of X. Number 2, compute the expected value, which we know, and the variance of x, of which we know. Then number 3, now we can apply what we were learning. Compute expected value of 2x, expected value of 5x plus 6, and expected value of 8, like that from this given question. Then number 3 or 4 rather, number 4 is compute variance of 2x plus 5. Variance of x minus 3x, like that. Okay, so let's do this. Let's do this. The students can copy the question, then we can proceed. So we take the average. Have the students managed to capture? So those with smartphones, you can capture, share in the groups so that also those with Techno and ITEL can have a clear view of what is here. Otherwise, if they try to capture with their Techno and their ITEL, we may see like the picture was taken in 2010 or maybe 2009 with the first camera. So those with iPhones, you can capture this, share in the group so that even your colleagues can have a clear view of what you are seeing. Okay, let's proceed. The students have captured this. Now let's start answering. The first thing is finding the value of x, which I doubt Is there a question? Oh, most definitely no question. Okay. So what we do is to find the value of a for number 1, we want the value of x. We apply a fact that summation of x times px, the fact that in a discrete probability, summation of all the probabilities sum up to 1. So this will help us find the value of x. So we'll say 0.15 plus 0.2 plus 0.18 plus x plus 0.3. All this should sum up to 1. Then people with calculators will help us find the value of x. So you have 3 minutes to help us find the value of x.
0.17.
So according to the young lady, she's saying 0.17. Is there anyone with a different value of x? Is there anyone who has a different value of x? Oh, there is no one opposing her, which means that's a fact. Okay, so with that fact, that's how you compute the value of x. So you can replace your value of x in that 0.17, like that. Then to find the expected value of x and the variance of x, you rewrite this your table. So we are going to have it written so that our computations are done in a good way. So we'll have it as x If you want, you can have it just down the way it is. So x, we have 1, 2, 3, 4. X went up to what's the value? So x is the number of patients, so we went up to 5. So number of patients up to 5. Then their respective probability, Px, we'll write them. So we have 0.15, 0.2, 0.15, 0.2, 0.18, their corresponding probabilities, then 0.17 and 0.3. 0.17 and 0.3. So the next thing that you do is you extend this your table. So what you have is that extend it, find the next, add the next column x times px. X times px. So what you do in those with calculators to quickly assist us. So can I have someone with a calculator? Myself, I don't have one. So someone who is very accurate, any volunteer with a calculator to assist us? Please, one volunteer to unmute and start giving us the answers as I'll be talking, the person will be giving us. Anyone to volunteer?
So for the first one, EX is 0.15.
So for the first one, it's 0.15. So what's happening is we are multiplying 1 times 0.15. So she's given us 0.15. The next one, 2 times 0.2.
0.4.
0.4, thank you. The next one, 3 times 0.18.
0.54.
0.54. The next one, 4 times 0.17.
0.68.
0.68. The next one, 5 times 0.3.
1.5.
1.5. Okay. Then you can do the total for this column. You can sum up these summations. So sum up 0.15 plus 0.4 plus 0.54 plus 0.68 plus 1.5. Can you sum that up for us?
3.27.
Sorry?
3.27.
My friend, I'm not getting what you're saying.
The answer is 3.27.
3.27.
27.
Good. Is there any opposition? Is there anyone opposing to this? So it means that, remember, our formula for expected value is summation of x times px. This is the formula. So what we've just done is we've summed up the xpx. So it means the expected value we've computed is 3.27. So the expected value is 3.27. Then let's extend. So this is the expectation, the expected value we've computed. That's the guy. Then let's extend the table so that it will help us find now the variance. So x squared px. So for x squared px, it means we are squaring x, then multiply with a probability. So when you square 1, multiply with 0.15, which will give us 0.15, because 1 is squared, which is just 1, times 0.15, it will just give us 0.15. We go to the next one. We have 2. So you square 2, and that will give you 4. So square this 2, gives you 4. 4 times 0.2. So 4 times 0.2, what do we get? 0.8. You square 3, then multiply with 0.18. So 3 squared is 9. So 9 times 0.18, what are you getting, guys?
0.62.
1.62, thank you. Then 4 square it, you get 16. 16 times 0.17. 4 you square it, you
2
get,
point,
sorry,
.72.
2.72. Get the 5, square it, and then multiply with 0.3.
That will give us 7.5.
7.5. So now, when you sum this up for us, please. Remember, expected value of x is 3.27. We've already found. How to find the
So I
value?
think the answer for 5 is it's 0.135 for x squared p5.
For which one, my guy?
For x is 5, it should be 0.135,
0.
not 7.5.
It should be what? 0.
Should be 0.135.